If a set contain n elements, then the number of all relation on A is. We have to find how many relation set A form. We know that relation from a set A to set B, then relation are subset of A cross B. And we know that number of relation are for relation, it is not for real set. Number of relation is always less than equal to number of all subset of this, all subset of A cross B subset. And subset of A cross B means indirectly we are talking about power set. Power set. So number of power set and number of power set, P for power set of A cross B, use square bracket here to clarify our distinctions easily. This is less than equal to power set of A cross B. If a set A contains n element, then its power set will be 2 raised to the power n. So we are seeking power set of A cross B. So we need number of elements of A cross B. So 2 raised to the power number of elements in A cross B, n for number of elements. This is number of elements in A cross B. Number of elements in A cross B is same as number of elements in A into number of elements in B. So this one equal to, or this inequality hold, NA into number of elements in B. Here A and B are here. A and B both are same. So this one equal to 2 raised to the power NA into NA. So this one equal to 2 raised to the power n. This n is different. You can understand this is denoting number of elements and this is number in set A, number of elements in set A. So you can make a script n to distinguish. So n into n means 2 raised to the power n square. Now which one option is giving this answer? Option A is correct choice. Generators in an infinite cyclic group is, every cyclic group has at least one generator, otherwise there is no generator, then we can't say group is cyclic. Cyclic means have some generators. So suppose group G is given and this is cyclic and has order of G is infinity or infinite, means no finite order. We know that every infinite group is isomorphic to Z plus or operation. I am not saying Z plus, it is understood. We know that this is infinite order and this is also infinite order and both are isomorphic, and number of generators of Z plus is 1 and minus 1, means only 2 generators. So this G is also have 2 generators because they are isomorphic. So almost all properties, either order generators or some other related properties, will be same for isomorphic group. So option B is right. And this is a theorem. Every infinite cyclic group has 2 generators. This is also a theorem. If you know the theorem, then you can directly tick the correct answer. In a group of order 66, the number of silo 11 subgroup is number of silos subgroup. NP can be find out 1 plus Kp, where 1 plus Kp divide order of the group, and K is from 0, 1, 2 and so on, means non-negative integer. So number of 11 silo subgroup N11 will be 1 plus K 11K divided by 66. You can write 66 as 6 into 11 or 2 into 3 into 11. This means that number of 11 silo subgroup will be 1 because K is only 0. If K equal to 1, then 1 plus 11 into 1 equal to 12 doesn't divide 60, so we can't choose this. If K equal to 2, then 1 plus 11 into 2 divided equal to 23 doesn't divide 60, so we can't choose K equal to 2 and so on. So value of K is only 0. This means that number of 11 silo subgroup will be 1 plus 11K when K equal to 0. This means that 1 plus 11 into 0 equal to 1. So only one 11 cyclos subgroup exists if a cyclos subgroup is unique of any order, then it is normal. So question can be transformed how many normal subgroup this 11 cyclo 11 silo subgroup exist. So option A is true. Total number of group homomorphism from Z12 to Z30 are, we have to find Z12 to Z30, we have to find number of group homomorphism. We know that both groups are cyclic. These two are cyclic group. So total number of group homomorphism, total number of group homomorphism from Zm to Zn are GCD of Mn. Here M and N are 12 and 30 respectively. So GCD of 12 and 30. Greatest common divisor. So answer is 6. Option A is true. If the order of the every element of a group is 2, then this group is abelian, is cyclic, is of infinite order, and is definitely non-abelian. Means for option associated this problem is given to us and we have to find correct options. Every element of this group has order 2. Suppose A is coming from this group G, then order of A is 2. This is true for all A. Sometimes whenever question is related to MCQ, then counter examples are very helpful to discard options. So well-known example K for clan for group. We normally know this is abelian abelian and finite. Also, if A is belong to K4, then A square is identity. This means self-inverse. Self-inverse. Other than identity, all elements have order 2 and identity has order 1. So this is finite. So option D discard here because is definitely non-abelian. This is abelian, K4 is abelian, and here, so option A might be true. B is cyclic. Option B is cyclic. K4 is not cyclic. So B discard here. Is of infinite order. This is false because K4 has finite order and order of this is 4 elements only K4 contain. So option C is also discard. So possibility of option A is now confirmed and A is true choice.